We're back. Long one. 17C. Same example. Because 0% was inside that interval, we can make a particular conclusion. 0% means zero difference, means no difference, means that in terms of females and males and the percentages that smoke at Cecil College, there's no evidence to say that a higher percentage of females smoke. Now, one word of caution. If you're testing for a difference, the number 0 or 0% is the key number. If you're doing an interval, same thing, for a difference in this lesson. When you go back to the previous lessons where we're just doing one sample, 0 may or may not be an important number, so I don't want you to take the 0 idea back to everything we've ever done and say, well, as long as 0 is in the interval, I can conclude one thing. That's not true. Because 0 is inside this interval for a difference, then we conclude, statistically speaking, that at Cecil College, there is no evidence a higher percentage of all females smoke compared to the males. Case closed. There's no evidence that a higher percentage of our females smoke compared to the percentage of the males. Well, we did the interval. What's next? Hypothesis test goes with an interval, right? They're both based on the same ideas, and let's do it. Part 9. Let's run the hypothesis test that we started back 2 videos ago. It's been a little bit of a while. Remember what we're testing, H sub 0. P for the females is equal to P for the males versus P for the females is exceeding P for the males, proportions of smokers. Okay? We will need to convert our data to the test statistic. So over here, let's just remember how we could summarize that data. I have the p-hat, right? Here's the data. P-hat for the females. Let's see if I can remember. This was 120-30, right? This is 25%. And the p-hat for the males, I think we had, what, 90 males, 18 smokers, 20%. Okay? There's the data. I got to convert that to a test statistic. And, well, here it is. Over here is the test statistic. We're still working with proportions, so essentially we're just converting it to a z-score. Up top, I take my difference. P-hat, females, but I'll just put 1 in general. P-hat, 2. Okay, it'd be females and males, but in general. I take the difference. So up top really is 5%, right? 25 minus 20. Down below, I need to divide this by some sort of standard error. And this is where things get a little bit tricky. This is the standard error of p-hat with the subscript pooled. So get that down. And then we're going to talk about it. The formula for this is coming on the next page. Let's just have a couple words. We're assuming up in the null, which we assume to be true to start, that the percentage of smokers for all females is equal. It's the same for the percentage of the males, right? So here's what we're going to do when we cook up the standard error formula. I'm going to take all of the data from both samples, females and males, and smush it together into one big sample proportion. Because remember, we're considering the null to be true to start. So I'm going to take all the data from both populations, which I believe to be the same when it comes to smoking, to start. Smush it together, pool it together, so that's called, it's not called p-hat smush, it's called p-hat pooled, right? Pool it together. Probably says this here. This is probably the nastiest formula we get to all semester, so you could just bear with me through 17C, then you'll be good to go for the rest of the semester. Here's the tricky part, top of the next page, right? Yes, it is. We're hypothesizing the proportions are equal. Up in the null, we're going to pool our standard deviations together rather than treat them separately. And so, yeah, we got some stuff to write here. Yep. All right, so here's the formula. Standard error of p hat pooled equals big square root, big one, all the way down here to the very end. Plus there right in the middle. So it's two things. I gotta pool it together, right? And here's what it turns out to be. I do a p hat pooled times, so 1 minus p hat pooled all over n1 plus same thing all over n2. So p hat pooled times 1 minus p hat pooled all over n2. That's that denominator in the test statistic. Now we'll do one by hand in the notes today, and then in Kim's videos I think she'll do one or two by hand, possibly, I can't remember. But in class there are a couple of technology tricks, so fight with it through the videos. It's good practice to use the formulas. What the heck is that p hat pooled? P hat pooled. Smush all that data together. I would take x1 plus x2 over n1 plus n2. How many smokers in the females plus how many smokers in the males goes up top. How many females plus how many males goes in the bottom. You're pooling those two samples together. So we'll put it in a box here. Right, for the smoking example at Cecil College, p hat pooled is going to be, oh, I forget, how many smokers did we have for the females? 30, right? 30. How many smokers for the males? 18. How many females? 120. How many males? 90. And so that's what the p hat pooled would be. Calculator, turns out that's 0.229. It's not a true average of the two proportions, so don't just divide the two proportions, add them up and divide by 2. It's sort of a weighted average, right? Notice that's in between the 25% females and 20% males. It needs to be, if you think about it, taking all that data and pushing it together. All right. Next bullet point down, we're going to compute the test statistic. So we will need to draw on this number, this 0.229 number, and we will apply this formula by hand. So that's where we're going here. Halfway down the page, now compute the value of the test statistic for the Cecil College example. Remember, we already know what we're going to do with this hypothesis test, right? Based on that confidence interval, there was no evidence for a difference. So we're expecting a small test statistic. We're expecting a large p-value. We're expecting fail or reject. And we're expecting to conclude no difference between the two, females and males. Here's the z. I'm just going to go right to numbers because I don't even know if it would fit if I recopied the formula with the letters. Up top, 0.25, that's the proportion of female smokers. Subtract off 0.20, that's the proportion of males. Over that big standard error of p hat pooled. And so there's the number we just calculated. I get a 0.229. 1 minus 0.229 all over how many females? 120. Plus 0.229. 1 minus 0.229 all over how many guys would be 90. And essentially what this test statistic is doing is answering the question. How unusual is that 5% difference once you scale it down in terms of standard error? I don't think it's going to be that unusual. Pause the video, see if you get what I got. I got a 0.853. Interpret that number correctly. I'm going to do it on the bottom corner here of this video. What on earth does that mean? It means this. It's simple. Don't make it complicated. Our p-hats were 0.853 standard errors apart. Case closed. Our two p-hats, the one for females was 25%. The one for males was 20%. They were less than one standard error apart. Is that unusual? Not at all. Fail to reject, right? What we have to do is convert this to a p-value. You know how to do it. We're just going to go to a normal model and we're going to shade under that normal model in the correct direction. All right? So, does this look messy? I agree. Are the ideas something you should know at this point? They are. All right? So let's do it. Bottom of the page. Tricky part is over. Test statistic follows a standard normal model, just like when we ran hypothesis tests for one proportion back in lesson 16. By hand, can you get that p-value? To get it, just shade under the standard normal model like we've been doing for the last 12 weeks of the semester. But right, so here's a z-curve. Standard normal model, centered at 0. The test statistic is going to go right about here. This is my z equals 0.853. Right, that's the test statistic. To get the p-value, I shade upwards. Why do I shade upwards? I would shade up because I'm running a greater than test. Remember, go all the way back to that. All the way back to the alternative hypothesis. I was saying more females than males. You've got to use the StatCrunch tool to get this answer. So I know you know how to do it at this point. And I'll just say from StatCrunch, I use the normal model tool. What did we get? We got 0.197. There's your p-value. By anybody's standards, this is failed to reject. We have no evidence whatsoever that difference that we observed in the samples would be unusual under the assumption that the null is true. Okay? Looks like, flip the page for 10. I don't want to get ahead of myself. Pause the video if you need to. Number 10, top of the next page, and we're finally just about done with this super long example, but we did it. Make a decision, write a concluding remark in the context of the problem. Since that p-value of 0.197, 197 is large. It's above 0.05. It's above anything reasonable where you would even think to start rejecting. Since that p-value is large, fail to reject the null. Right? That's the decision part. Now write one sentence to wrap this up in context. I guess we could say, at Cecil College, there is no evidence that a higher percentage of females are smokers. At Cecil College, there's really no evidence that a higher percentage of females are smokers. I think it's implied compared to males. I'd be fine if you put the period there, but for completeness sake, I'll parenthetically add this, compared to the males, right? There's no evidence a higher percentage of our females are smokers. So I guess all that anecdotal evidence, seeing all the nursing students who are primarily females in their scrubs outside smoking on break, was just that, right? It wasn't statistical evidence. Let's take a peek here. Okay, that wraps about up. There's no, you can see at the bottom of that page, things are getting a little complex in terms of the formulas, so it is summarized for you. You've got that as a reference at the bottom of the page. That's it for me in this lesson. Kim's got the last two, so thanks for watching. We'll see you in the class.